This is benzene. This is hydroxybenzene or phenol. This is also known as carbolic acid. Hydroxybenzene. Another compound, benzoic acid. Let's write another compound with both the functional groups, hydroxyl group and carboxyl group. This is the compound with both the functional groups, hydroxyl group and carboxyl group. The name of this compound is ortho hydroxy benzoic acid. Carboxyl group and hydroxyl group, they are at ortho positions with respect to each other. Hydroxyl group is at ortho position with respect to carboxyl group, and carboxyl group is at ortho position with respect to hydroxyl group. Let us consider hydroxyl group is at ortho position with respect to carboxyl group. Then the name of this compound is orthohydroxy benzoic acid. It has another name, that is common name, salicylic acid. Important compound in organic chemistry, salicylic acid. In this lesson, we are going to learn preparation of salicylic acid through Kolbe reaction. Kolbe reaction after German chemist Hermann Kolbe. Let's see Kolbe reaction and its mechanism. Kolbe reaction, the chemical reaction in which salicylic acid is prepared from phenol. Let's see reaction. First of all, phenol is treated with base sodium hydroxide. Then phenol or carbolic acid reacts with sodium hydroxide to form salt sodium phenoxide or sodium phenolate, and water is formed as byproduct. This is reaction number 1. Reaction number 2, this sodium phenolate or sodium phenoxide is treated with carbon dioxide gas. Then sodium phenoxide turns into sodium salicylate. This is sodium salicylate. Again, this sodium salicylate is hydrolyzed in presence of acid. As a result, sodium salicylate converts to salicylic acid. Sodium chloride is formed as byproduct. Here, at the time of passing carbon dioxide through sodium phenolate, pressure is applied, 4 to 7 atmosphere pressure, and the reaction is carried out at around 125 degrees Celsius temperature. This is the reaction by which phenol is converted to salicylic acid. This reaction is known as Kolbe reaction after German chemist Hermann Kolbe. What is the definition of Kolbe reaction? The chemical reaction in which phenol is converted to salicylic acid, and in this case inclusion of carboxyl group occurs at ortho position of phenol. This reaction is known as Kolbe reaction. Now let us see mechanism of Kolbe reaction. Mechanism. Step 1. Phenol reacts with base. We know phenyl group benzene ring is a kind of electron withdrawing group. This bond undergoes heterolytic fission. Electrons of oxygen hydrogen bond move towards oxygen. As a result, this hydrogen gets freed as proton. This proton combines with this hydroxyl group, and as a result, water is separated from the reactants. This minus sign indicates separation of the compound. Now, this is formed. Oxygen with negative charge. This is known as phenoxide ion or phenolate ion. Again, these lone pair of electrons turn into bond pair. Here actually there are two electrons. Now electron-electron repulsion occurs. To reduce this electron-electron repulsion, pi bonded electrons turn into lone pair of electrons. As a result, this is obtained. Carbon oxygen double bond. Carbon oxygen single bond turns into carbon oxygen double bond. Orthocarbon carries negative charge. It has one hydrogen atom. This is obtained from step 1. Step 2. These species hydrogen negative charge reacts with carbon dioxide at 4 to 7 atmosphere pressure and at 125 degrees Celsius temperature. At this condition, carbon dioxide gets polarized. Oxygen is highly electronegative element than carbon. Here, around carbon, positivity is created. As a result, this carbon and carbon dioxide carbon form a new bond. As a result, this is obtained. This carbon and this carbon form a new bond. Carbon oxygen double bond. Here hydrogen. Carbon carbon new bond. Carbon oxygen double bond. Here carbon oxygen single bond with negative charge. This negative charge, because here pi bonded electrons move towards oxygen. That is why this ion is formed. In this ion, oxygen is electronegative element, pi bonded electrons move here, oxygen becomes negative in charge. These carbon hydrogen bonding electrons turn into carbon carbon double bond. This hydrogen gets freed as proton. This proton combines with this oxygen, negatively charged oxygen. As a result, this is obtained. Now, carbon oxygen double bond turns into carbon oxygen single bond. Hydrogen, this hydrogen with this oxygen. Here, carbon oxygen double bond, oxygen minus charge. Now, in this carbon, no hydrogen atom. Hydrogen atom from this carbon combines with this oxygen to form hydroxyl group. Let's see next step. Step 3. This ion hydrogen, here carbon oxygen double bond, oxygen with negative charge. Sodium ion present in the solution combines with this oxygen which carries negative charge to form this compound. Hydrogen, here minus plus. Here double bond is formed. This carbon hydrogen bond changes to carbon carbon double bond. Here double bond. This double bond here. Now this species is hydrolyzed in presence of acid. Then this compound converts to this compound OH, carbon oxygen double bond. This oxygen will get proton from this acid, that is salicylic acid. Sodium chloride is formed as byproduct. We got salicylic acid. Salicylic acid through Kolbe reaction. This is the mechanism of Kolbe reaction. If this lesson benefits you a bit, please subscribe to the channel. No more today. Thank you very much.